everyone. Today we will solve this question. It was asked in UPSC Civil Service exam in 1994. It's quite a very good question. So you will not find this book. You will not find this question in MD Rising on your any other book, but you will find the required knowledge to solve this question in MD Rising and other books. So let's see what is the question and what are the two approaches to it. First is choose what we already know. With little manipulation, we can reach to the solution. I will discuss that approach in this video. The second approach is, okay, that I discussed. There is an example. There is an example in MD Rising India. This finds the PD for cones with vertex ABC, which is which is what is required in this question. But the problem is, in that question itself, it has given the equation of a cone. It says the equation of a cone for vertex at ABC is of the form f of the function of z minus c y minus b upon z minus c. So if you know this, you can directly write this and solve this question. This is a 10 mark. But this is not a standard result. So obviously, we don't know it. And when we solve a question, we don't remember the question statement. So it was very hard to know this, that you have to use this function to solve this question. Right. Now, what is the other way? Because this is very difficult to know. What is the other, a conventional way, a way which can reach, like with using which you can reach to a solution? The way is, we all have studied this. We know the standard equation of cone, right? We know this standard equation of cone, and from that we can find the equation of cone with vertex at origin. You all have must done this question also from PD, where you have to find the equation of the PDE of cones with vertex at origin. You can use that to find this question, and it can be easily done. Let's see what is the approach. Okay. So there's a simple concept of shifting of origin, right? The problem is, I don't know the standard equation for a cone with a given vertex ABC, in this case 2 minus 3 1. But if I shift the origin to the point 2 3 minus 1 in some coordinate system, then I can easily find the equation using my knowledge of equation of a cone passing through origin, and then I can find the PDE as well in that coordinate system. So let's find that. If I want to shift the origin, I can assume capital X is equal to X minus 2, capital Y is equals to Y plus 3, and capital Z is equal to small z minus 1. If you see in this coordinate system, this point is getting reduced to 0, 0, 0, 0, that is origin, right? Now, equation of cone with vertex at origin is ax square plus by square plus cz square, okay, plus 2f yz plus 2g xz plus 2h xy equals to 0. This is the equation of cone with vertex at origin. So I will use the same equation in the new coordinate system. My equation will be ax square plus by square plus c capital Z square plus 2f yz capital by capital Z plus 2g capital X capital Z and 2h capital X capital Y equal to 0. Now differentiate with respect to capital X. I will get 2ax. This will become 0. Then 2cz into p that is del z by del x plus 2fy into p plus 2cz plus 2z x into p, right? And 2hy is equals to 0. This is the first equation. If you rearrange it, you can write it in the form ax plus gz plus hy plus p times cz plus fy plus gx equals to 0. Call this as equation 1. Similarly, differentiate with respect to capital Y. Okay, and we will get 2by plus 2cz cube plus you see here 2fyz, it will give you 2fy into q plus 2fz plus here 2gx into q plus 2hx is equals to 0. Rearrange it. You get by plus fz plus hx plus q times cz plus gx plus f into z. This is the second part. So to simplify it, but what we will do is we will multiply the first equation by x, multiply the second equation by y, and add. This is a standard thing that we did. Okay. So by doing that, you will get ax square plus by square plus 2hxy okay, plus see here you will get gxz plus fyz plus ex plus qy times cz plus fy plus gx is equals to 0. Is equals to 0. Now we know that ax square plus by square, we know that that this term, okay, we know that ax square plus by square plus 2hxy plus 2f the terms plus 2g is equals to 0. Okay, cz square is equal to 0. So for this ax square plus by square plus 2hxy can be written as minus cz square minus 2f minus 2f xz by z minus 2gx. Putting this in the equation, instead of ax square plus by square plus 2hxy, we will get minus cz square minus 2 minus 2fyz minus 2gxz plus fyz plus gxz plus px plus qy into cz plus fy plus gx is equals to 0. So simplified further, you will get cz square minus fyz minus 2gxz minus gxz plus px plus qy times cz plus fy plus gx equals to 0. If you take z common from here, minus z common from here, you will get cz plus fy plus gx plus ex plus qy into cz plus fy plus gx is equals to 0. I can write it as px plus qy minus z times cz plus fy plus cx equals to 0. Okay, I can ignore this term. This will be my required differential equation. So my differential equation, partial differential equation is px plus qy minus z equals to 0. Or you can say px plus qy is equals to capital Z. Right? This is the differential equation for any cone with vertex and origin. But this is in the capital X, capital Y, capital Z system. What was capital X? It was P of x minus 2 plus q of y plus 3 is equals to z minus 2. So this will be your final answer. What I actually did is I used what I knew, that I knew how to find the partial differential equation for a cone with vertex and origin, and I used that knowledge. I tweaked it a little. I found the solution of the given problem. So what was the main steps? Okay, so the first step was step 1, shift origin to given point, right? Then step 2, find PDE of cone with vertex at origin. What is the final step? Substitute the values. That's it. Like you put capital X equal to x minus 2 here, then substitute x minus 2 in place of capital X. Capital Y was y plus 3, then substitute this value. Right? Capital Z was z minus 1, so substitute this value. You find the partial differential equation in the original coordinate system. That's all. So I hope this was helpful. Have a good day.